This story opens with laughter. Not on a battlefield, not over the wreckage of burned-out tanks, but in a dim, smoky briefing room outside Moscow. A group of Soviet generals and intelligence officers lean over a projector, squinting at a grainy schematic of America's newest experiment in armored warfare. It is 1978, the Cold War is near its peak, and on the screen is something so absurd to them, so hilariously misguided, that a colonel cannot help himself. He chuckles, then laughs, then openly mocks what he is seeing. An aircraft engine in a tank. He taps the schematic with his pointer. An American M1 tank, what the world will soon know as the M1 Abrams. To the men in that room, veterans of a nation that defeated Nazi Germany with simple, rugged machines built by the tens of thousands, this is not a revolution. It is a joke. A heavy, overcomplicated, fuel-guzzling monstrosity that will, in their minds, drown in the first muddy field of West Germany. What they don't realize is that they're not laughing at a mistake. They're laughing at their own funeral. Imagine this. You are a Soviet tank commander, trained your entire career to believe that your T-72 is the sharpest steel fist on earth. You've memorized tactics built on speed, mass, and shock. You've been told that the American Abrams is a fragile, fuel-thirsty diva that will crack under real war. And then one night in a sandstorm, your tank explodes. Before you even know where the enemy is, in today's video, you're going to discover how a tank that the Soviet Union mocked as a paper tiger turned out to be a dragon in the dark. How one miscalculation in a smoky Soviet briefing room rippled forward for more than a decade and ended up rewriting the rules of modern war. If you're fascinated by Cold War technology, real military strategy, and the hidden stories behind possible weapons, make sure you stick with this video until the end. There's a twist here that goes way beyond tanks. It's about why one superpower collapsed and the other didn't. And hey, before we roll into the first chapter of this story, if you love deep dive documentaries about the Cold War warfare and game-changing technology, tap that like button, subscribe to the channel, and hit the bell icon so you don't miss the next episode. It really helps this kind of long-form content reach more people who love these stories as much as you do. Let's go back to that room in 1978, and to the laugh that started it all. The briefing room lies buried inside a fortified GRU compound outside Moscow. The air is thick with cigarette smoke, the windows are dark, and the walls are covered with giant maps of Western Europe. Thick red arrows stab across them toward a single fateful bottleneck, the Fulda Gap. This is the imagined battlefield where East meets West, where Soviet armor will someday thunder into NATO territory. On the projector screen is a technical schematic, black lines and circles on white paper, copied and recopied until the image is grainy but still readable. This document is the Soviet High Command's first real glimpse of America's new main battle tank program, the XM1. At the back of the room, a GRU colonel with a flat, unimpressed expression stands up. He has the wary authority of a man who has spent his career around diesel fumes and steel plate. He wraps the schematic with a wooden pointer, and with a smirk delivers his verdict. They're putting an aircraft engine into a tank. Laughter rolls through the room. One of the generals at the front, his chest glittering with medals, exhales a cloud of blue smoke and adds a joke of his own. An aircraft engine. Are the Americans planning to fly over the Fulda Gap? Another wave of laughter. They go down the list of specifications. Weight, already projected at 55 tons, likely to climb to 60 once the full armor package is added. Compared to that, the Soviet T-64 sits at around 36 tons. The T-72, around 41. These are compact, lean, aggressive machines. The American tank, in their words, is a pig-heavy, slow, a logistic nightmare. The colonel shakes his head. Maintenance will be a disaster. Fuel consumption will be outrageous. The turbine engine will suck kerosene like a bomber. In their analysis, the Americans are building a tank that needs a small army of mechanics and aerospace engineers just to keep it alive. On paper, they're not wrong. On paper, the Abrams looks like everything Soviet design philosophy hates: large, complex, expensive, and hungry. Meanwhile, the T-72 is the distilled essence of Soviet practicality: small, low, hard to hit, and brutally efficient to build. And in 1978, sitting in that room, who could argue with them? But here's the key question: how do you lose a war you never fought? To answer that, we need to understand the machine the Soviets loved, and the machine they mocked. To grasp why the Soviets were so confident, you have to understand what the T-72 represented to them. The T-72 wasn't just a tank, it was a philosophy made of steel. It sat low to the ground, barely 2 meters tall. In silhouette, it presented a tiny target, something that could vanish behind small rises in the terrain or disappear in the rolling folds of European farmland. It carried a powerful 125 mm smoothbore gun which, in the late 1970s, could kill any NATO tank that dared to show itself. But its real magic, the part that made Soviet engineers proud, was the autoloader. Instead of a fourth crew member to manually load shells into the breech, the T-72 used a mechanical carousel system. Rounds sat in a rotating drum beneath the crew compartment, and a mechanism fed them into the gun automatically. This meant three things: one less crewman to train and house, where a smaller turret, because no one had to stand up inside it to ram rounds. Higher theoretical rate of fire, because the autoloader never got tired. In Soviet terms, this was genius. Fewer crew meant cheaper tanks. Smaller tanks meant lighter vehicles, faster to produce and easier to transport. Mechanization meant efficiency. The T-72 could be built fast in huge numbers and maintained by soldiers with basic tools and training, in workshops and depots. A T-72 could be fixed with what amounted to a hammer, a wrench, and a handful of spare parts. It could cross rivers, charge across frozen ground, and tear through dry steppe at terrifying speeds. For Soviet planners, it was the perfect instrument for their preferred way of war: massed armored assault. The doctrine behind that assault was called deep battle. Instead of obsessing over individual tank duels, deep battle focused on breaking the enemy system. You don't just fight the front line. You punch through, drive into the rear, and smash supply lines, command posts, and airfields. You cause the entire enemy structure to collapse within 48 hours. In this vision, the T-72 is not a duelist. It's a scalpel used in bulk, a tool designed to carve through NATO's front lines and never stop. When Soviet intelligence officers looked at the Western tanks of the day, the German Leopard 1, the British Chieftain, the American M60, they felt confident. Their T-72 was at least equal, and often better in firepower and size. They believed their doctrine and their machines were ready. So when word arrives that America is about to field a 60-ton turbine-driven behemoth with a voracious appetite for fuel, their instinctive reaction is simple. We've already seen this movie. The Americans are making the same mistake the Germans made with the Tiger. But were they, or was something else happening? Something the Soviet system simply couldn't see. The Soviet skepticism didn't come from ignorance. It came from experience soaked in blood. In World War II, they had watched German heavy tanks like the Tiger and Panther dominate individual engagements, but lose the war. Those machines were marvels: thick armor, big guns, advanced optics. They were also nightmares to maintain, slow to produce, and few in number. By contrast, the Soviet T-34 was simple, crude by comparison, and produced on an industrial scale. It broke down less, was easier to repair, and existed in such massive numbers that it overwhelmed the sophisticated German designs. To Soviet planners, the lesson was brutally clear: complexity is the enemy of reliability. Elegance loses to quantity. You don't need the best tank, you need enough good tanks. So when analysts read reports about the M1's gas turbine engine, complex electronics, and high fuel consumption, it triggered all their deepest suspicions. They heard rumors of engines failing in dust and sand. They heard that American mechanics struggled with new computerized diagnostics. They saw budgets ballooning. Every new piece of information seemed to confirm the story they already believed. The Americans are building a showpiece. We are building an army. Yet beneath this solid wall of confidence, a small, uncomfortable question lingered. Why? Why would the richest, most technologically advanced country in the world, one that had landed men on the moon, pour billions into a tank that seemed obviously flawed? Was it incompetence, corruption, a scam by defense contractors? Or was it something much more dangerous, that the Americans understood a future of war the Soviets could not yet imagine? Because here's the twist. The M1's most important secrets weren't visible in any schematic. They were literally hidden inside the armor and in the dark. Stay with this video, because in a few minutes, you're going to see how a tank that looked terrible on paper became a nightmare in practice, for the people who laughed at it. Throughout the late 1970s and early 1980s, the Soviet intelligence machine went to work. The GRU and the KGB's technical branches activated agents, interrogated sources, and collected scraps of data about the new American tank. They debriefed military attachés who attended NATO demonstrations, pored over satellite photos of American test ranges like Aberdeen and Fort Knox. We collected trade journal articles and technical glimpses from Western publications, listened to rumors about performance problems, maintenance headaches, and the enormous cost of the program. But their investigation had a fatal flaw. They weren't trying to discover what the Abrams really was. They were trying to confirm what they already believed. When early reports mentioned a new composite armor, based on a British development known by a code name they would come to know as something like Chobham, their reaction was not alarm. It was skepticism. After all, Soviet institutes were already pushing the edge of armor technology. Laboratories like Stoli were leading in explosive reactive armor, bricks strapped to tanks that detonated outward to disrupt incoming shaped charge warheads. Lightweight, clever, efficient, very Soviet. By contrast, the Western approach seemed primitive, just pile on more passive armor. Thicker, heavier, more steel. To them, that was a dinosaur mindset. Their analysts ran calculations. To stop one of their new long-rod penetrators, a tungsten dart traveling at well over 700 meters per second, a tank would need the equivalent of several hundred millimeters of solid rolled steel. To protect against modern-shaped charge missiles, it would need even more. If the Abrams weighed around 60 tons, there was simply no way, using conventional materials, that it had the protection its designers claimed. So they concluded the Americans were bluffing. Maybe the composite armor was just a fancy layered steel setup, expensive, overweight, but not truly revolutionary. They assumed their own tungsten penetrators, like their Mango rounds, would slice through it. Then there was the engine. The Honeywell AGT 500 turbine looked like a logistical nightmare. Its exhaust plume would light up infrared detectors. Its shrill whine was so distinctive that crews joked you could hear an Abrams from miles away. And the fuel consumption, staggering. The Abrams drank kerosene like a dehydrated soldier drains vodka. On top of that, its range was significantly shorter than their own diesel-powered machines, including their experiment with a gas turbine T-80 that still kept a diesel safety net. From inside the Soviet bubble, it all added up. This tank was too thirsty, too complex, and too dependent on fragile electronics to be survivable in the chaos of a real battlefield. They didn't realize they were misreading the entire equation. Quick reminder, if you're enjoying this deep dive into Cold War miscalculations and hidden tech, hit the like button and drop a comment with your favorite tank, T-72, Abrams, Leopard, or something else. It really helps decide which stories to cover next. Now, let's break down the three big theories the Soviets built their doctrine on, and why each one failed catastrophically. From the mountain of reports and technical data, Soviet analysts crystallized their view of the Abrams into three core ideas. These weren't just opinions, they became doctrine. 1. The logistical leash theory. The first belief was simple: the Abrams could not operate for long without an enormous chain of fuel trucks tied to it like an umbilical cord. In a fast-moving, deep battle, where Soviet armored columns would push 50 to 100 kilometers per day, American tanks would run dry quickly and be left behind. In this view, the war would be decided within the first 48 hours, long before NATO could establish stable supply lines for such fuel-hungry beasts. 2. The brittle glass electronics theory. The second belief targeted the Abrams' complex electronics. Its digital fire control system, laser rangefinder, wind sensors, and most mysterious of all, its thermal imaging system. These were all seen as fragile luxuries. In Soviet tanks, optics were simple and rugged. Night vision used active infrared spotlights, clumsy and limited but understandable. In contrast, an intricate network of sensors and computers seemed like delicate glass ready to shatter under the constant shock of artillery, rough terrain, and battlefield chaos. Their conclusion: in real war, these systems would fail. The tank would go blind. Once that happened, all its supposed advantages would disappear, and the T-72 with its basic optics would thrive. 3. The failed doctrine theory. Finally, there was a deeper, more philosophical belief that the Americans still didn't understand what tanks were for. Soviet tanks were instruments of offensive maneuver. They were meant to surge forward, smash through, and keep going. But looking at the weight and fuel appetite of the Abrams, Soviet planners decided it was not an offensive weapon at all. It was a glorified tank destroyer, a defensive system meant to sit in prepared positions, wait and fire from static lines. Too heavy to maneuver at the pace of deep battle. Too fragile and complex for the mud, the cold, and the shock of rapid offensive warfare. Summarized, their verdict was harsh and absolute: the Abrams is clumsy, fragile, short-legged, and doctrinally misguided. And that verdict shaped everything. These views were taught in academies, baked into training manuals, repeated in briefings. Tank commanders drilled tactics based on swarming the Abrams, closing to close quarters ranges, hitting its flanks, and overwhelming it with sheer numbers. They believed they had solved the puzzle. They didn't realize they had been solving the wrong puzzle. Because while they were training for the brawl they expected, the United States was quietly preparing for a completely different kind of fight. Let's step out of Moscow and cross the world to the dusty test ranges of the United States. At places like Aberdeen Proving Ground in Maryland, engineers and soldiers worked in heat, dust, and noise to hammer the Abrams into something that could survive not just mechanical testing, but a terrifying piece of arithmetic. That math problem looked like this: the Warsaw Pact could potentially deploy around 50,000 tanks. NATO at best had around 15,000 to oppose them. On a straight numbers basis, NATO would be overrun. In a conventional, symmetric duel, they would simply be crushed by quantity. So the American solution could not be more tanks. They were never going to match Soviet mass. The only viable solution was to build tanks so capable that each one could fight like many. They needed a machine that could see first, shoot first. A kill with the first shot, survive return fire, do it again, and again. They weren't designing a better T-72. They were designing a silver bullet, a system where each tank was a force multiplier, a predator in a battlefield full of prey. That's the key shift the Soviets never grasped. While they imagined the Abrams as a clumsy giant, its designers saw it as a hunting platform, a 60-ton package of speed, armor, and information that could dominate engagements before the enemy even understood they were in danger. Let's break that silver bullet system down into its three pillars: armor, mobility, and eyes. First, the armor. The Soviets were right about one thing: the Abrams was heavy. But they misunderstood what that weight was buying. At the core of its protection was a new type of armor derived from British research, a laminated composite that no one in Moscow had truly experienced in combat. Instead of relying on a single thick slab of steel, this armor used layers of metal, ceramic, and empty spaces arranged in a complex matrix. Against a shaped, charged weapon, like a hot round that forms a superheated jet of metal to punch through armor. The ceramic layers disrupted and scattered that jet, turning a focused spear into a broken, useless spray. Against a long rod penetrator, those fast-moving darts of dense metal, the incredible hardness of the ceramic could blunt or shatter the tip, while the backing layers absorbed and deflected the remaining energy. In simpler terms, the Abrams wasn't just armored. Its armor actively worked against the physics of incoming projectiles. It didn't merely stand there and take it. It was engineered to ruin the attack itself. Philosophically, this was the opposite of Soviet priorities. Soviet design accepted that tanks, and their crews, were expendable. Tanks were cheap, mass-produced weapons. If one died, another took its place. Crews were often conscripts, minimally trained and easily replaced. American design choices made a different assumption: crews were highly trained professionals, expensive to recruit and develop. They were not disposable. So the tank's primary job was not just to carry a gun, it was to keep its crew alive. The Abrams was not a cheap, rugged brawler. It was a mobile fortress designed around the idea that the people inside it were invaluable. But armor would mean nothing if the tank couldn't move. And this brings us back to the turbine engine, the aircraft engine in a tank that had caused so much laughter in Moscow. To Soviet ears, a turbine engine in a tank sounded insane. Turbines are high-revving, hot, and notoriously thirsty. In an era of diesel engines, this looked like a pure vanity project. But American planners were trading fuel for something else: raw, violent acceleration. In the 1970s, diesel engines, especially large ones, tended to be noisy and slow to respond. They took time to build power. Turbines, by contrast, could spool up quickly and deliver immense power on demand. In practice, this meant that a 60-ton Abrams could launch from a standstill to around 30 miles per hour, roughly 48 kilometers per hour, in under 7 seconds. For a vehicle of that size and weight, that's startling. To a Soviet tank crew used to the lag of a traditional diesel, it was almost unnatural. This explosive acceleration created a new tactical option: shoot and scoot. An Abrams could crest a ridge, stop just long enough to take a precise shot, fire, instantly reverse back behind cover before the enemy's return fire, launched from 2,000 meters away, even reached the position it had just left. In that time window, a T-72, with its more sluggish engine response, would be stuck in place far longer, essentially waiting to be hit. Yes, the turbine consumed more fuel than a comparable diesel. Yes, it required a robust supply chain. But in exchange, it turned a supposedly clumsy tank into a sprinter. It enabled tactics that Soviet doctrine was simply not designed to counter. The Abrams was not meant to crawl forward in a slow armored wall. It was meant to dart, strike, reposition, and always fight on its own terms. But even speed and armor pale next to the tank's real superpower. The final, and most important, piece of the puzzle was the one the Soviets understood the least: the Abrams' advanced electronics, especially its thermal imaging system and fire control computer. Soviet night fighting capability at the time relied mainly on active infrared. Tanks projected invisible IR light onto the battlefield and used sensors to see the reflected energy. It worked, sort of, but it had major drawbacks: limited range, a poor performance in smoke, fog, or heavy particles. And, most crucially, it turned the tank into a beacon. Any enemy with IR viewers could see the flashlight itself. The Abrams used a completely different approach: passive thermal imaging. Instead of shining light, its sensors detected heat. Warm engines, hot exhausts, even friction-heated tracks glowed against the cooler background. This meant no emissions to give away its position. The ability to see through smoke and dust. On the ability to see through total darkness. On the Abrams, this thermal view fed directly into a digital fire control system. When the gunner placed the crosshair on a target, say the glowing shape of a T-72 at 2,500 meters, and pressed a button. A laser rangefinder silently measured the distance in an instant. The system then combined that information with data about heat crosswind, ammunition temperature, barrel wear and flex. All of this went into the ballistic computer, which adjusted the gun's elevation and aim automatically. For the gunner, the process became almost deceptively simple: laser, confirm fire. The expectation was not walk rounds onto target. It was first round hit. On top of that, the Abrams introduced hunter-killer capability. The tank commander had his own independent, stabilized thermal viewer. While the gunner engaged one target, the commander could be scanning for the next. As soon as he found it, he could slave the turret to his sight with a button press, swinging the gun onto the new target almost instantly. So while a T-72 crew might struggle to spot, range, and hit one enemy in the dark, an Abrams crew could identify, prioritize, and kill multiple targets in rapid sequence. This wasn't a tank in the old sense, it was an assassination machine. But all of this, the armor, the engine, the sensors, remained, for the Soviets, theoretical, a rumor, a ghost, until 1991, when a sandstorm in Iraq turned theory into horror. The Cold War's great tank duel was supposed to happen in the fields and forests of Central Europe. Every Soviet plan and NATO counter-plan revolved around the Fulda Gap, the North German Plain, and the roads, rivers and towns of West Germany. Instead, the decisive test of these rival philosophies took place in the open desert of southern Iraq. By 1991, the Soviet Union was staggering, but its military doctrine lived on in client states. One of the strongest of these was Iraq's Republican Guard, an army with Soviet-style organization, training, and equipment. Its officers had trained in Moscow. Its doctrine was deep battle. Its armored spearhead was built around T-72s, export versions slightly downgraded but still formidable machines. These crews had fought in the brutal Iran-Iraq War. They were not inexperienced. They were dug into defensive positions, camouflaged and ready. They believed they understood what tanks could and could not do. They had no idea that the battle about to hit them would not be a brawl. It would be a slaughter from beyond the range of their vision. The date is February 26, 1991. The place, somewhere in the featureless desert, along a grid line that will later enter military history as 73 Easting. A violent sandstorm, known as a Stormel, whips across the landscape. Visibility drops dramatically. Dust and sand fill the air, swirling in choking clouds. For Iraqi crews dug into their revetments, this seems like a gift. Their active infrared night systems can't cut through the dense sand. The pressure of the storm turns the battlefield into a blank wall. From their perspective, the storm is a shield. Nothing could possibly maneuver in this. Nothing could see them. So they wait, engines idling, crews sweating in the dark, listening to the wind howl around their turrets. Then, faintly at first, they hear something strange. Not the rumble of diesel engines, not the clank of tracks. A high-pitched whine, like a jet engine, but on the ground. The sound seems to come from everywhere and nowhere. A distant whisper, carried and distorted by the storm. Before they can piece it together, a T-72 in their line vanishes in a blinding flash. The tank's turret is ripped from its hull, flung into the air by an internal explosion as ammunition cooks off. The shockwave hits neighboring vehicles. Crews are stunned, confused. Some are already dead and don't know it yet. Seconds later, another tank explodes, then another. From inside the Iraqi line, the world has descended into chaotic terror. They are under attack, but they have no targets. They see no enemy. They see only darkness and sand. For the Americans, the scene looks completely different. On the US side, units like Eagle Troop of the 2nd Armored Cavalry Regiment are moving forward, probing deep into Iraqi territory. Their Abrams tanks are stationary or creeping at low speed, hulls still and stabilized. In their thermal sights, the sandstorm barely exists. Instead of dust and darkness, gunners and commanders see a world of contrasts: cool ground, warm engines, hot exhausts, faint glowing lines where tracks have churned over the sand. Iraqi T-72s appear as bright, rectangular shapes, their engines and turrets like lanterns in the dark. The American crews are calm. For them, this is an extension of years of training at home. This is Aberdeen proving ground with live targets. Gunners laze targets, get instantaneous range data, see the firing solution indicator light up, and pull the trigger. Depleted uranium penetrators scream downrange faster than the speed of sound, striking Iraqi tanks whose crews are still trying to figure out what's happening. Suddenly, a T-72 turret disappears from the gunner's thermal view, not because it ducked behind cover, but because the entire vehicle has been destroyed. The crew moves on to the next target, then the next. Target, fire, target destroyed, next. From the Iraqi perspective, it is a massacre. Their shells fly out into the storm, fired roughly in the direction of noise and flashes. They hit nothing. They are shooting at ghosts. In roughly 20 minutes of savage, one-sided combat, A handful of Abrams tanks and supporting vehicles shred an entire Iraqi battalion's worth of armor. Not a single Abrams is lost to enemy tank fire. The storm that Iraqi crews trusted to protect them has instead turned into the perfect backdrop for the Abrams advantages. A stage on which all the misguided Soviet assumptions are exposed in the harshest possible light. When the dust of Operation Desert Storm settles, the numbers tell a brutal, undeniable story. Over roughly 100 hours of ground combat, Abrams tanks in various versions destroy thousands of Iraqi armored vehicles, including large numbers of T-72s and other Soviet-designed tanks. In return, only a tiny handful of Abrams are permanently lost, and none of those are confirmed kills from enemy tanks. Crews walk away from catastrophic hits that would have killed them in older designs. In many cases, the armor and the tank's internal layout prevent ammunition from cooking off in the way it did in T-72s, where stored rounds sit beneath and around the crew. The logistical leash that was supposed to doom the Abrams never materializes as a battlefield weakness. Its operational readiness rate stays impressively high. Fuel is delivered, tanks keep moving. The turbine proves not to be a fragile liability, but a reliable power plant refined through years of testing. The brittle glass. Electronics don't shatter under war's shock. They become the most decisive edge in the conflict, the instruments that allow American crews to see, decide, and kill before the enemy even knows they're exposed. The failed doctrine of the heavy defensive tank dissolves. The Abrams shows that it can maneuver, exploit, and dominate in offensive operations, turning open desert into a killing field where it writes the script of the battle. For Soviet strategists watching this from a collapsing empire, the implications are devastating. The tank they laughed at in 1978, the pig that would supposedly drown in the mud, has just danced across the sands as an apex predator. The diva with the turbine engine has stayed in the fight. The paper tiger has revealed itself as a dragon, and the tanks that embodied their philosophy, the T-72s built for mass, simplicity, and expendability, have become props in someone else's lesson plan. After the shock of Desert Storm, Soviet and post-Soviet analysts scramble to understand what went wrong. Some already knew the gaps were growing. Others are horrified by how wide those gaps truly were. They rush to respond. New generations of explosive reactive armor, like heavier contact blocks, are strapped onto tanks. They develop advanced guided missiles that can be fired from tank guns, hoping to hit Abrams at longer ranges. They try to create rounds that can defeat composite armor. But at a deeper level, they are trying to fix the wrong thing. The problem was never just the thickness of armor or the power of the gun. Those are important, but they are symptoms, not the disease. The real problem lies in the Soviet philosophy itself. The T-72 was an evolution of the T-34, a tank designed in an era where the primary way to win was to build more, accept losses and push forward. It was a masterpiece of iteration, refining proven concepts and making them more efficient. The Abrams, by contrast, was a product of innovation. It wasn't simply a better M60, it was a reconception of what a tank is, and not just a gun on tracks, and not just an armored box, but a platform built around sensors, information processing, crew survivability, and long-range lethality. The Abrams was a system of systems. The Soviet industrial and political model, with its centralized control and suspicion of open competition, struggled to generate the kind of microelectronics ecosystem that made Western fire, control computers and thermal images possible. You can steal a chip, you can copy a circuit, but you cannot easily replicate the messy, competitive, trial and error environment that created them at scale. The Soviet Union had built an empire on imitation copying bomb designs, reverse engineering aircraft matching Western capabilities with good enough versions churned out in massive numbers. But the Abrams wasn't just a thing you could copy. It embodied a way of thinking that the Soviet system simply wasn't structured to produce. In the end, the story of the M1 Abrams and the T-72 is not just a story about tanks. It's a story about arrogance. When those Soviet officers laughed in 1978, they weren't just laughing at a schematic. They were laughing at what they believed was Western decadence. Wasteful, overcomplicated, soft. They thought they had solved the puzzle of war once and for all. They stopped asking uncomfortable questions. They saw chaotic debates, program delays, and budget fights in the West and mistook them for weakness, instead of recognizing them as the messy engines of innovation. They thought the future of war would be a refined version of the past: more tanks, better tanks, same basic rules. The Abrams was the answer to a question they never seriously asked. What happens when the enemy can see you, and you cannot see them? In the desert of Iraq, under the cover of a sandstorm, the answer came from 3,000 meters away. The answer arrived in silence, in a faint turbine whine, in the glow of thermal images and the invisible pulse of laser rangefinders. It arrived as tanks exploding without warning, as crews dying before they knew they were under attack. That answer didn't just kill tanks, it killed a doctrine. It killed a mindset. It helped finish off a superpower that had already rotted from the inside by proving that its central military myth, that mass and simplicity would always prevail, was no longer true. If you've watched this far, you're clearly the kind of person who loves understanding the real story behind the headlines and the hardware. So let's make a deal. If this video gave you a new perspective on tanks, the Cold War, or how technology shapes power, hit the like button. Tell us in the comments in a hypothetical head-to-head, which would you rather command, an M1 Abrams or a T-72, and why? And if you want more deep dive stories like this, from stealth aircraft to submarine standoffs, make sure you're subscribed and that you've rung the bell icon so you don't miss our next upload. Because here's the thing. The Abrams wasn't the only weapon the Soviets misread. There were other systems, hidden aircraft, silent submarines, secret networks, that they also underestimated or misunderstood until it was too late. If you want to see how another one of those paper tigers turned out to be something far more terrifying, click on the next video on your screen. The laughter in that Moscow briefing room was the sound of an empire that thought it understood the future. The real story of the Cold War is how often it was wrong.